Okay, you got trig identities. I think I gave you 2 pages of graphs. One was from the inside cover of some, I think, your book last year. And one is I graphed them on my calculator. And the other one is the unit circle. Because all the trig values are based on the unit circle, yeah? Did you guys have to make unit circles last year? Okay, so, which of course means the speed quiz is coming up very soon. Is it tomorrow? Okay, then Thursday, I guess it is then. Thursday and Friday are the speed quizzes then. But then we might have a regular quiz on Thursday or Friday as well. So speed quiz, Thursday and Friday. Anyway, this Friday is the end of the mid-quarter. After I pass back your test today, some of you are going to realize the gravity of the situation, and we need giant numbers on the quizzes. Anyway, come on, speed quiz. You already know the answers before you even start, right? Anyway, this is what the speed quiz is going to be like. You're going to have 20 of these. It's just sine, cosine, and tangent only. Sine 7 pi over 6. Tangent 3 pi over 2. Cosine 4 pi over 3. You're going to have 20 of these. 1 point each. Right? You know the answers, right? They're all in the unit circle that I just drew. I mean, I gave you, right? And then the next speed quiz is sine, cosine, tangent, and secant, cosecant, and cotangent as well. But once you know these 3, the others you just flip it over, right? Take the reciprocal, right? Like for example, if you know cosine of 4 pi over 3 is -half, then, why am I writing that? -half, then secant of 4 pi over 3 is, you just flip it over. It's the reciprocal this way. -2. If you know tangent of 3 pi over 2 is undefined, therefore cotangent of 3 pi over 2 is 0. It's the reciprocal, that's why, right? We need another example. If sine pi of, I'm not going to give any examples. Okay, so how do Mr. Park, what do we do with these trig values? Look at your unit circle that I gave you. What do I do? Do I just memorize them? No, you don't memorize. That's for babies. You visualize, because if you just memorize, then you forget, right, the next day. You visualize where they are in the unit circle. Okay, so let's do a quick geometry review before we even... All of these are based on 30, 60, 90, and 45, 45, 90 triangles. In a 30, 60, 90 triangle, if the hypotenuse is 1, then what's the length of the short leg? Half, because it's always half the hypotenuse, and the long leg is always going to be radical 3 times this, so you get root 3 over 2, right? Do you notice that these are the trig values? And then in the 45, 45, 90 triangle, I was shocked. Oh, never mind, I can't say anything. In a 45, 45, 90 triangle, if the hypotenuse is 1, what are the 2 legs going to be? This is on the SAT, people. If you know the side, how do you get the hypotenuse? You multiply by radical 2. So going the opposite direction, what do? You divide by radical 2. So this is 1 over root 2 and 1 over root 2. Okay, this is our geometry review. Now we can study trigonometry. Okay, all of trigonometry is defined on the unit circle. It's a circle of radius 1 centered at the origin. That's why they call it the unit circle, because the radius is 1. Now, I'm assuming we remember at least the basics. Whenever we measure angles, you always start from the positive x-axis, right? So that's 0. Okay? So, and then of course the terminal side of the angle will intersect the unit circle at some point, right? So let's start at 0 then. Now everything in this class is done in radians, so we're not going to do any degrees. How did you guys memorize them last year? Degrees or radians or both? Both, okay, well that's good. But we're just only doing radians because that's the way it's going to be in calculus next year. So, but before we even go on, do you even know what a radian is? You guys know what 1 degree is, right? Like how many degrees are there in a circle? 360. So if I divide a circle up into 360 parts, right? then one of those parts is 1 degree, right? What's a radian? What if I were to ask you what's a radian? You're in a Turkish prison. The only way you can get out is you got to tell me what a radian is. Hanaoka, what is it? What's 1 radian then? Just tell me what's 1 radian. And you guys in physics should be ashamed of yourself if you don't know. Okay, here's a circle. Here's the radius of the circle. The radian measurement of that angle is equal to... Okay, what did we learn in physics? Or last year in Algebra 2? How do you get the arc length over here? Arc length is equal to r times theta, right? Theta got to be measured in radius. Therefore, theta is equal to the arc length divided by r. So the radian measurement of an angle is the arc length divided by the radius. That's what a radian measurement is. So when the arc length is equal to the radius, then what is that angle measurement going to be? If these two things are equal, then the radian measurement is 1. So 1 radian is when this arc length is equal to the radius. And that occurs about what? Come on, these are things you got to know. What is 1 radian about? Zhang, give me an approximation, like 30 degrees, 40 degrees, 50, what? What is 1 radian? Okay, let's go back to basics. What if we want to convert 1 radian to degrees? Let's do dimensional analysis. How do we do that? How do I change 1 radian to degrees? Well, you want to multiply by degrees over radians, so the radians cancel out, right? So we know from last year that 180 degrees is equal to pi radians, right? So the radians cancel out, so you just get 180 over pi. Now, pi is a little bit bigger than 3, right? So what's 180 divided by 3? 60. So what's 180 divided by a little bit bigger than 3? A little bit smaller than 60. That's right. So 1 radian is just a little bit smaller than 60 degrees. In fact, if you want to know, 1 radian is approximately 57.3 degrees. Come on, in physics, you guys memorize that, don't you? Apparently not. Oh boy. I mean, because when we talk about radians, you gotta kind of have a visual of what it is. It's about 57.3 degrees. That's what it is. Okay, that was the review. How many times are we gonna have to review? Go back. This is review. Okay, so what's an angle measurement of 0? Where would that be? That would be right here, right? I hope you guys remember if you go counterclockwise, that's positive, and negative is clockwise, right? You guys remember that? Okay. So a measurement of 0 radians would be the same thing as 0 degrees. That would be right here. Now, wherever the angle, the terminal side of the angle intersects the unit circle, what are the coordinates at this point? This is 0 radians. 1, 0. The cosine of the angle is equal to the x-coordinate, and the sine of the angle is simply the y-coordinate of where the terminal side intersects the unit circle. Okay, so what about like a 90-degree angle? What radian measurement is that at a 90-degree angle? Come on, pi is 180 degrees, so 90 degrees is pi over 2. What are the coordinates at this point up there? 0, 1. Therefore, by definition, cosine of pi over 2 is 0. Sine pi over 2 is 1. Cosine is the x-coordinate, sine is the y-coordinate. It's that simple. I don't know how you, what did you guys do last year? Just memorize flashcards. And that's the problem. So you guys don't conceptually know what it is. What is the, okay, 180-degree angle? What radian measurement is that? Pi. What are the coordinates at this point? -1, 0. So therefore, cosine of pi is -1. See, that's the x-coordinate. Sine of pi is equal to 0. Okay, what about a 270-degree angle? That's 3 pi over 2. That would be right here. What are the coordinates at this point? 0, -1. That's why the cosine of 3 pi over 2 is 0, and the sine of 3 pi over 2 is -1. And then, of course, 2 pi is the same thing as 0, right? And then it just keeps on going. It repeats. So from 0, so on the speed quiz, I'm only going to give you angles from 0 to 2 pi. You're not going to get anything bigger or smaller than that. Because I figure once you know those, you guys can add or subtract multiples of 2 pi, right? I'm not going to give you like, what is the cosine of 2700 pi over 6? You know what I mean? I'm just going to give you angles between 0 and 2 pi. I'll make it this. What about last year? I heard last year, didn't they give you like big angles and you had to reduce them down? Like, what is the cosine of 1000 degrees? I'm not going to give you that, okay? Just between 0 and 2 pi. What do we call angles that lie either on the x or the y axis? Those are called quadrantal angles. See how easy quadrantal angles are? It's either 0, 1, or negative 1, right? Okay, but what about the angles that are in between? See, that's the one students have trouble with. Okay, let's start off. 30-degree angle. In a 30-degree angle, what's the radian measurement? Pi over 6. What are the coordinates of this point? See, that's why we did the review. When you make a 30, 60, 90 triangle, this is 30, this is 60. If the hypotenuse is 1, this is a half, and this is root 3 over 2, right? So what are the coordinates of that point? Oh, root 3 over 2, comma 1 half. That's why the cosine of pi over 6 is root 3 over 2, and the sine of pi over 6 is equal to 1 half. Cosine is the x, sine is the y. It's that simple. So all you do is you visualize where the angle is. And that okay, for example, okay, what if you had to do this? What is the cosine of 3 pi over 4? The first thing you do is visualize where is 3 pi over 4. That's over there, right? That's a 135-degree angle. So if you draw your reference triangle like this, if that's 1, what are these two? 1 over root 2 and 1 over root 2. Therefore, what are the coordinates of this point? Negative 1 over root 2, comma 1 over root 2. Therefore, the cosine of 3 pi over 4 is negative 1 over root 2, and the sine of 3 pi over 4 is positive 1 over root 2. It's just the x and y coordinates at that point. Cosine is the x, sine is the y. See, whenever you make a 30, 60, 90 triangle, you can get root 3 over 2, 1 half, right? And 1, of course, because it's a unit circle. The longer one is root 3 over 2, the smaller one is 1 half. When you draw a 45, 45, 90 triangle, then both of these are going to be 1 over root 2, right? So instead of memorizing flashcards, you just visualize. You know what I'm talking about? Okay, so this is the way I do it. You can pick it up, or if you want to just purely memorize it, you can, but you're going to have to memorize it until you quit math, you know, because you're going to see it in calculus next year. You take more calculus at college. You got to know your trig values and identities until you quit math already. I want to quit right now, Mr. Park. That's just that. Okay, what is the cosine of, say, 7 pi over 6? Okay, this is what should go in your brain. Where is 7 pi over 6? It's over here. Okay, what is the x coordinate of that point? Because it's cosine, right? Well, obviously it's negative because you got to go to the left, right? Negative, but how much do I go to the left? Well, if you draw your reference triangle, do you go plenty to the left, or a little bit to the left, or medium to the left? Plenty. So that's why negative root 3 over 2. So that's why, look, anytime you draw 30, 69, or 45, 45, 90, the only values you're going to get are, okay, of course, 1 and 0, but I'm not going to do those. Root 3 over 2, 1 over root 2, or 1 half. Small, medium, large. Yeah. Wait, let me look. Yes. So 0.5, 0.707, 0.866. These are the decimals for each of these numbers. See, small, medium, large. So all you got to do is ask yourself, okay, where you are in the unit circle, is it positive or negative? Is it small, medium, or large? That's what I do. Okay, so here, let's do another one. What is the sine of 5 pi over 3? Yeah. Oh, I thought I saw a hand up. Where is 5 pi over 3? 5 pi over 3 is right there. Sine is the y coordinate of that point. Is the y coordinate of that point positive or negative? It's negative because it's below the x-axis, right? And how much do I have to come down? Small, medium, or large? Large! So it's negative root 3 over 2. Are we catching on? I'll go make flashcards tonight. No, you don't make flashcards. You do it. Okay, what is the cosine of 11 pi over 6? Okay, this is what you think in your brain. Where is 11 pi over 6? It's right there. What is the x coordinate of that point? First of all, positive or negative? Positive, because it's to the right of the y-axis. And then how much do I have to go to the right? Plenty large, so it's positive root 3 over 2. It's that simple, people. What is the sine? What is the sine of 2 pi over 3? Okay, where is 2 pi over 3? It's up there. What is the y coordinate of that point? It's positive, and then how much do I have to go up? Large, so root 3 over 2. Whenever you make a 30-69 triangle, people, see how one is large and one is small. One side is large, one side is small. Okay, what is the cosine of 5 pi over 4? Where is 5 pi over 4? It's right there. What is the x coordinate of that point? Well, it's negative because you got to go to the left, right? Negative, and how much do I go to the left? Medium, so root 2 over 2. Now, I don't care whether you write 1 over root 2 or root 2 over 2, they're both the same thing. But I'm going to tell you right now, I'm sure your teacher told you last year, 1 over root 2 is better. Why? Because it's faster to write. It might be. But then, what happens when you take the speed quiz when you got secant, tangent, and cotangent? You got to flip over, right? See, if it's 1 over root 2, you flip it over, you get root 2, and you're done, right? But if you go root 2 over 2, if you flip it over, you're going to get 2 over root 2, and then you got to simplify that to root 2. Because root 2 over root 2 is not simplified, that's why. You know what I'm talking about? So that's why 1 over root 2 is better. You flip over, you get root 2. But it's up to you. You can do whatever you want. I'm just giving you hints of it. Oh, so that's easy, Mr. Park. Sine, cosine, tangent. Small, medium, large. Okay, now, what about tangent now? Well, what do we know? What is tangent? Tangent is equal to sine over cosine, right? So, if you look at your unit circle, look, it got the coordinates of all the points right there, yeah? All you have to do is go sine over cosine. In other words, you take the y coordinate and divide it by the x coordinate. So this is what I would suggest. On that unit circle I gave you, next to the point, you should go this. What is this divided by that? 0 over 1 is 0. So you should write that number there. That's the tangent right there. What is 1/2 over root 3 over 2? 1 over root 3. Oh, is it better to write 1 over root 3 or root 3 over 3? Yeah, 1 over root 3, so then when you flip it over for the cotangent, you just get root 3. Okay, what about that pi over 4 over there? This is 1 over root 2, 1 over root 2. So what's tangent? What's sine over cosine? 1. Okay, what about at the 60-degree angle at pi over 3? So this is pi over 4, this is pi over 3. What are the coordinates of that point? 1/2 root 3 over 2, right? Because you got to go small to the right and big up, right? Okay, so what's the tangent? What's this divided by that? Root 3. And what about 1 divided by 0? Undefined. Now do not, every year on the speed quiz, I put tangent pi over 2. You know what students write? They write this. What the heck does that mean? Empty set. Or does that mean phi, which is 1 plus root 5 over 2? That's the golden ratio. No, the proper term is undefined, because you're dividing by 0. This means empty set. That means no solution. That has a totally different meaning than undefined, although some of you probably think they're the same thing. No solution is like an equation that has no solution. Undefined means it's not defined. That's the same thing, huh? No! Now I want you to notice something about tangent. Tangent starts at 0, and then as you get closer to the y-axis, it gets bigger, bigger, bigger. So for tangent, this is the small, medium, and large for tangent. So it starts at 0, and as you go toward the y-axis, it gets big. So when you are close to the x-axis, tangent is small. When you get closer to the y-axis, tangent gets big. So now, let me show you how to do tangent now. So what if you have to go tangent 2 pi over 3? Okay, where is 2 pi over 3? It's over here, right? Okay, first of all, is tangent positive or negative in the second quadrant? Okay, now at no point am I going to teach you all students take calculus like your teacher taught you. That's for babies. That's like FOIL. Okay? Tangent is negative here because sine divided by cosine. Sine is positive and cosine is negative, right? So tangent is going to be positive here and here. It's going to be negative here and here. You're going to do all students take calculus. No way. So in the second quadrant, tangent is negative, and since you're close to the y-axis, it's going to be big. Okay. Okay, what's the tangent of 7 pi over 6? Okay, 7 pi over 6 is here. It's in the third quadrant, tangent is positive, and you're near the x-axis, so it's going to be small. Because you're close to the x-axis. Close to the x-axis, small. Close to the y-axis, big. What is tangent of 7 pi over 4? Where's 7 pi over 4? It's right there. What quadrant is that? Fourth. In the fourth quadrant, tangent is negative, and it's right in the middle, so medium, right? So that's how I do my trig values. I just think, the first thing I think, is it positive or negative? And then do I think small, medium, or large? Oh, but Mr. Park, then, if you're going to use your method, you got to know where all the angles are. Duh. Well, if you look at your unit circle. You know, if you were to just draw your own unit circle just on your own, you probably would get all these values down already. But then see, I gave it to you. I'm spoon feeding you. I don't know if I'm helping you or not. But if you would sit down and just do your own unit circle and do exactly what I have there with the tangent, it's so easy. It's ridiculous. Okay, so the quadrantal angles are 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? Okay, what are the angles that are close to the x-axis? That's the pi over 6 family, right? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. I call it the pi over 6 family. The angles that are close to the y-axis, that's the pi over 3 family. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then what are the ones that are right in the middle? That's the pi over 4 family, right? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. See, if you can do what I'm doing, then it's like nothing. So any questions on that? So this is the way I do it in my head. I don't know how you have to figure out what's going to work for you. I just go make flashcards. No! Okay, if you want to, I can't stop you from doing it, but flashcards means you're just memorizing and then you're going to be in trouble later. Because this is not just memorizing for this quiz and it's over. You got to memorize until, like I told you, until you're done with math. Because trigonometry is a basic function, the trig functions. You got to know that. Okay, any questions on that? Okay, let me see tonight's homework. What do you have to know for tonight's homework? Oh, you got a graph. Okay, now that we know the trig values, you know how people last year they studied for the speed quiz, they're staring at the unit circle. You should draw it yourself. You should know by now, math, you learn by doing. You cannot just study notes. If that's the case, then I just put up a, what do you call that thing? What do you call that thing? You just put it up and you start talking. PowerPoint. Then I just put PowerPoint up. Why do I do all this stuff on the board? Math, you gotta do. Okay, now what about graphing? Okay, so the next thing you gotta, okay, the first real quiz, you gotta know your 6 basic graphs. Okay, let's start out with y equal cosine x. How do you graph that? Well, first of all, you gotta know your values, because if you don't know your values, how the heck are you gonna draw the graph, right? So here's 2 pi, 1 and negative 1. Okay, what's cosine of 0? So I don't know, maybe you guys should think of the unit circle. What's cosine of 0? What's the x coordinate at that point? 1. And then pi over 2, what's the x coordinate there? 0. What's the x coordinate here? Negative 1. What's the x coordinate there? 0, and then we'll go back to 2 pi, it's the same thing as 0, right? So you just plot the quadrantal angles and then, ooh, you guys know what cosine looks like, right? And then of course, this is just one period. This is not the whole graph. This graph goes on forever to the left and the right and just repeats itself, right? What do you call a graph that just repeats itself after a certain amount? It's periodic. Now what's the period for cosine? 2 pi. So every 2 pi units, it just repeats itself. So when you draw graphs, as long as you draw me at least one period is good enough, because I think at this stage, everybody knows how to copy and paste, right? Or do I have to make you draw 3 periods for homework? Come on, copy and paste. Okay, now what about sine? What does sine look like? Y equals sine x. 1, 2, 3, 4. What time is it? Oh my gosh. We didn't even have time to go over the test. Oh, and oh my gosh. So many atrocities on the test. You're just making up your own rules. It's like. Anyway, sine is the y coordinate. So what's the y coordinate here? 0. And then 1. And then you just think of the unit circle. Duh. Right? Then and then of course it just keeps on going, right? What about tangent? Okay, now the main thing is you know what one period of the graph, because once you know what one period is, the rest is just copy and paste, right? So here, just to save time, right? This is how I remember tangent. Tangent at pi over 2 is undefined, right? That's why you have vertical asymptote there. Okay. And then if you just plot points, okay, what is tangent over here? 0, and then 1. So 0, and then 1. So tangent's gonna look like this, right? So notice that the period for cosine and sine are 2 pi, but what's the period for tangent? It's pi. And then it just starts repeating again, right? It's periodic. Now, once we know the graphs of cosine, sine, and tangent, how do you graph the reciprocal graphs? How do you graph y equals secant x? How did you guys learn last year? Secant is 1 over cosine. It's the reciprocal. So what you do is, every point on this graph, you take the reciprocal of it. So what's the coordinates of this point? What's the y coordinate? 1. What's the reciprocal of 1? 1. What's the reciprocal of 1/2? 2. What's the reciprocal of 0? Undefined, so you don't get vertical asymptote. Did you guys learn this last year? So whenever the graph touches the x-axis, the reciprocal of 0 is going to be undefined, so that's when you get vertical asymptote. So the graph starts here, and then when you take the reciprocal of fractions, what happens is it gets bigger, so the graph humps up like that. So I'm sure you learned last year, if the cosine graph is humping down, then the secant graph humps up. So if you hump up here, then you hump down over there. If the thing is humping down, then you hump up. Right? Isn't that how the graph is drawn in your book? Just the humping technique. So like right here, same thing with sine. If you want to graph cosecant, which is 1 over sine, then hump. Look, when it crosses the x-axis, you get vertical asymptotes because the reciprocal of 0 is undefined. And so the graph humping down, you hump up. If the thing is humping up, you hump down. Yes or no? How did you guys learn last year? Plot points. Or hump. Oh, I want to know, what did you guys learn last year? Hump. What about tangent? Can I use a humping method for that? No, because there's no humps. Where's the hump? You show me a hump, I'll give you a nickel. No humps on tangent. Okay, so here, if we were to continue this graph, okay, here, this is what tangent looks like, right? So we have to take the reciprocal of this graph if I want to graph cotangent. Y equal cotangent x is the reciprocal of tangent. Okay, so what's the reciprocal of 0? Undefined. So whenever it's 0, that means it's going to have vertical asymptote. What's the reciprocal of undefined then? 0. What's the reciprocal of 1? What's the reciprocal of -1? Yeah, so that's why cotangent just comes down like that. It's very simple. But when you guys just want to memorize stuff, that's what makes it complicated. Okay, so what do I want? Okay, here, this is what I want when you draw. This is what I want to see when you draw graphs tonight. Graph this, y equal 2 sine 3x. So again, you got to know your 6 basic graphs, and then you're going to do stuff to it. But then, just like on the test we took on Friday, oh my gosh, the first 2 problems, you just do stuff to that graph, but you're doing all the wrong stuff. Oh my gosh. Okay, what does one period of sine look like? 1, 2, 3, 4, 2 pi. And here's 1 and -1. What does sine look like? Wow! Right? Okay, this is what I want. What does this do to the graph? It multiplies the x coordinates by 1/3. What does this do to the graph? It multiplies the y coordinates by 2. There, I'm done. Why are you laughing? That's what you're supposed to do. You don't redraw the graph. Oh, I gotta make it, you gotta shrink it and stretch it. Yeah, by changing the scaling you do it. You know what I'm talking about? But do not ever do this, because I remember last year 2 people did this on the quiz. They go, oh, because it had a negative sign in the front, so they do this. Make down minus and make down plus. You cannot do that. I forget who they were. Koga? No, that was 2 years ago. Koga and Tanikawa Lau. Okay, anyway, oh my gosh, there's only 8 minutes left. Okay, let me pass back the test. I guess we're not going to get to discuss it that much. You can just take your stuff and go.